Hello everyone. So for chapter 18, I wanted to focus on blood typing as well as its interactions with antibodies and the consequences that happens, because that seemed to be something that needed to be explained a little bit more than just what can be easily picked out from the lecture. Also wanted to point out a few things that were highly detailed things that I don't want you to know, don't want you to focus on, but I left them in the lecture just because I wanted you to at least have the idea that it's not a very simple process. So moving on to the blood typing. So in this section there was a lot of vocabulary. So the 4 vocabulary words that needed to be picked up were antigen, which unfortunately is not on this page. Antigen, which is a global family name for the cell identity markers that are unique to an individual. So if you remember the glycocalyx term from last semester. So these cell identity markers are different for each person unless you are a identical twin. So one of those types of antigens is called a agglutinogen. So those cell identity markers are specifically for the A, B, O blood types. So these agglutinogens for the type A blood type has the agglutinogen, type B has the agglutinogen. For the type O blood type, they have neither agglutinogen, so they do not have the A or B agglutinogen. For the AB blood type, they have both A and B agglutinogen on their red blood cell surfaces. So as a protective measure, the blood types make antibodies against the other blood types. So your A blood type makes a agglutinin, which is a type of antibody, against the B agglutinogen because it only has the A agglutinogen in its blood, so on the surface of those red blood cells. So your A blood type makes only the anti-B because that's the only agglutinogen that it needs to make an antibody against, since the O blood type does not have either one. So A makes the agglutinin against B. B makes the agglutinin against A. Since the O blood type does not have an agglutinogen for A or B, it makes agglutinins or antibodies against both the A and B agglutinogen. For the AB blood type, since they have both agglutinogens, they make no antibodies against a blood type. So what happens is your type O blood, since it has no agglutinogens that will react with an agglutinin, type O blood is considered your universal donor. For type AB, because they do not have agglutinins against either of the ABO blood types, then they're considered the universal acceptor. On top of your ABO blood types, you also have a blood type against for the C, D, E agglutinogens, but your D agglutinogen is the most reactive, and therefore it's the one that we focus on. So here in this section, talking about the D agglutinogen, so it's an additional agglutinogen on top of the ABO blood type. So if you have this agglutinogen, you're considered positive for it. So someone with a blood type that also has the RHD agglutinogen is considered A positive. If they do not have that agglutinogen, then they're considered A negative. And this goes for all of your 4 blood types. Individuals that have the agglutinogen for the positive Rh factor do not make antibodies or agglutinins against that Rh factor, so the Rhd factor specifically. But someone who is Rh negative, if they are exposed to Rh positive blood, then they will produce antibodies against that Rh factor. So, for example, if they're exposed to the Rhd one, then they'll produce antibodies against it. So now on to your blood typing, so determining the type of blood. So if you remember earlier, I talked about the inside the plasma, the different blood types make antibodies against the other blood types. So to test a person's blood to see what type of blood they have, we can take a sample of blood and add the antibodies that would be in the other blood types. So here at the top, we have this blue vial. That's your anti-A agglutinin or antibody against the A agglutinogen. The other side has your yellow vial of your anti-B agglutinins, so antibodies against the B agglutinogen that's on the type B blood. So in each of these little sections, you have a sample of blood. Each column was tested against the either anti-A or anti-B antibody. So we can determine that this at the top is a type A blood sample because it reacted or clumped up when it was exposed to anti-A antibodies. So this is from the external environment. So just because there was a little bit of mix-up about whether or not there was a blood type, as in which ones produce which ones, but this is outside of the blood testing for which blood type it is. So clumping in this sample, that makes it type A against the A antibody. Here we have clumping in the B column because it's compared to the B antibody. However, on this side, there's no clumping because in this type B blood, there's no A agglutinogens and therefore no reaction against the A antibody. For the type AB blood, there's reactions in both samples because they have both the A and B agglutinogen, so therefore they'll react with both A and B. For type O, there's no reaction at all because the type O blood has neither A or B agglutinogens. On the last slide, we saw the clumping where your blood samples were exposed to those antibodies. So in real life, if someone was exposed to the wrong blood type, so for example, someone with type A blood was exposed to a sample or transfusion of type B blood, then the antibodies in the type A blood, so in the plasma, are against the B antibody and therefore would cause a reaction with the B blood that was transfused into that person's body. So this reaction is called agglutination. So the antibodies here in green, those will bind to the agglutinogens or the antigens on the surface of the transfused blood and therefore causing clumping since these antibodies can bind to multiple red blood cells, therefore causing them to group up or clump. This clumping causes the mismatched transfusion reaction. So when these clumped red blood cells travel through the body, they eventually will break apart or hemolyze, therefore releasing their hemoglobin. So once this hemoglobin is released, then it will end up blocking those tubules inside your kidneys. So inside your kidneys, these little tubules help to filter out your blood. So with all this extra hemoglobin that hasn't been able to be processed and broken down into taking off the heme group and breaking down those globin proteins into their individual amino acids, this extra hemoglobin ends up blocking those kidney tubules, causing acute renal failure. So this isn't an immediate death sentence. However, this person would have to undergo dialysis because of the renal failure or kidney failure, and hopefully would be able to get a kidney transplant. So going back to blood typing and dealing with interactions between agglutinogens on the red blood cells and antibodies that are in the body, or agglutinins, it becomes an issue when dealing with the Rh factor in having a Rh negative mother that is exposed to that Rh agglutinogen through their fetus. So up here at the top, we have this mother who is pregnant with this Rh negative mother that's pregnant with an Rh positive fetus. So when this, after the fetus is born, so baby's born, the mother then develops antibodies against the Rh agglutinogen. The problem happens when she gets pregnant again with a Rh positive fetus. Then the antibodies that were in her body will then attack the fetus. To prevent this from happening, once they've tested the mother's blood and realized she's Rh negative, tested the child's blood and realized that the child is Rh positive, after birth, the mothers are given a shot called Rogam. This prevents the mother from producing anti-D antibodies against the Rh factor. So this helps when she becomes pregnant with her second child. There are no antibodies in her body that could attack the child, so therefore she has a safe baby. On to some things I don't want you to focus on. So moving on to your white blood cells, and we're talking about leukapheresis. So leukapheresis is the formation of your white blood cells. So similar terms dealing with your erythropoiesis, that's the formation of your red blood cells, and your thrombopoiesis, which is the formation of your platelets, so forming that megakaryocyte, and then the platelets are the cell fragments off that cell. So back to leukapheresis, so the formation of white blood cells. You start off with your hematopoietic stem cells, which will then differentiate into a type of blast cell. So in our case, dealing with our myeloblasts, which forms our neutrophils, our eosinophils, and basophils. Monoblasts eventually will differentiate into monocytes, and then your lymphoblasts will eventually become your lymphocytes, and those lymphocytes are then later tested in the thymus for their ability to function. So in this slide, I do want you to know that once those red blood cells are released from the bone marrow, they do stay in the bloodstream for a short period of time, but then can later live in the tissues for a lot longer. So they go from the bloodstream, stay there for a short while, and then eventually leave and go to the tissues. So after your hematopoietic stem cell differentiates into the different types of blast cells, so they go from your stem cell to your colony forming units, then to your blast cells. I don't want you to know all the different random steps to get to your mature leukocytes. I do want to point out here, of course you guys can count and realize that this is more than 5 cells for your leukocytes. So up top you have your eosinophils, your basophils, your neutrophils, your monocytes, and then these last 3 are your 3 different types of lymphocytes that we'll cover in the next module. They're different functions, so you have a B lymphocyte, a T lymphocyte, and a NK cell. So lastly, just some stuff I don't want you to focus attention on dealing with platelet function. So On this slide showing the different pathways and how they cascade with these different factors that help move along the process of coagulation, so clotting of the blood. I don't want you to know which step goes with which factor goes with which. So with these last few slides where it has all these steps on which factors go here and who helps whom, ignore those. I'll just left those in there so you can know that there's a bunch of steps to eventually getting to a clotted blood. And then also with the dissolution of a clot, again, a bunch of steps that I don't want you to pay attention to. Just knowing that eventually after the skin is healed, then that blood clot has to be removed. So that's the end of my Chapter 18 highlights. Again, if you have any questions, please message me through Blackboard or stop by my office. My office hours are posted on Blackboard off to that little side menu. So I'm here for you just as much as I would be a student that's in a face-to-face classroom. So thanks for going over the Chapter 18 stuff, and eventually soon I'll post Chapter 19. Thanks. Bye.